Okay, let's briefly talk about mapping suppressors. A suppressor is a second locus, so we had our original mutant and then we had a second locus that was masking its auxotrophic phenotype. Because we're dealing with two loci, now we can talk about linkage. In fact, what one has to discuss when you've identified that a suppressor is in play, you have to think, is it a heterodimer or non-heterodimer? And you also have to ask linkage. Are they linked with one another? Let's just do a few thought experiments to see how this would play out. What would you expect if you had an unlinked non-heterodimer suppressor? So if we took this, if our revertant was an unlinked non-heterodimer suppressor, so we've got MET1 plus and now the suppressor, MET1 minus, and the suppressing allele. So this is our new revertant, and we cross that to wild type. And then that gives us our four genotypes. What would we expect if this was an unlinked non-heterodimer and we took this and plated it on minimal media plus methionine and then plated it over to minimal media? So we'd have our four genotypes. Okay, so there's our four different genotypes. And what we said before, we knew that this one would be prototrophic in all cases because it's the original suppressor suppressing the MET1 minus mutant. Here we have plus plus, so that will be prototrophic as well. And here we have minus with the wild type allele of the suppressor, which we will know is always auxotrophic, regardless whether it's a heterodimer or a non-heterodimer. Here's the one that we always have to worry about because it's the new recombinant genotype. In the case of a non-heterodimer or a pathway suppressor, what we're dealing with in this situation is that this would have a prototrophic phenotype. So if this is an unlinked non-heterodimer suppressor, the recombination frequency that you would expect would be 50%, which means that the two recombinants, so let's just now label these as recombinant or non-recombinant. So this one's non-recombinant, this one is a recombinant, plus and plus is one of the non-recombinants, and then the last one is a recombinant. So we would expect to see, say if we plated 1,000 spores, if this is a haploid fungus, we would expect to see 250 of every genotype, which would mean that on the minimal media plus methionine plate, we would have our 1,000 spores. And on minimal media alone, only the one auxotroph genotype will not grow. So we would see 750 that grow on minimal media, because we would have these prototrophs. These three genotypes would be prototrophic. So for an unlinked non-heterodimer suppressor, you would expect to see this pattern in the offspring. If we look at this same cross, except now say, well, what if it was an unlinked and a heterodimer suppressor? Then we would have to go back and say, okay, this genotype will always be auxotrophic, but this other recombinant genotype will also be auxotrophic in this case, so not prototrophic. So with a heterodimer suppressor, we have those two auxotrophic genotypes. And in this case, with the supplemented media, we would still have our 1,000 spores, but on minimal media, we would only see 500 that show up because there's only two prototrophs now and two auxotrophs. So if you ever see this pattern, actually this is a case where you have the most possible auxotrophs in this particular type of cross. If you see that there's only 50% prototropes and 50% auxotropes, that immediately tells you that it's a heterodimer suppressor and that it's unlinked. An unlinked non-heterodimer suppressor, as we saw previously, would produce 3/4 prototropes and only 1/4 auxotropes. So that's a quick and easy way to see the difference. We'll discuss linkage now. It's a little bit trickier with linkage because we can't always determine with certainty what the different genotypes are and what their proportions are. So we'll turn to that next. Now that we've discussed unlinked suppressors, it's time to discuss the possibility of linkage. With a linked suppressor, we're still faced with this issue of deciding whether or not we're dealing with a non-heterodimer or a heterodimer suppressor. With linkage, things are a little bit more complicated, and we'll discuss how that plays out. As always, when we have a phenotypic revertant, we cross it to wild type and we plate on supplemented media and then replica plate onto minimal media. In this case, if this is what we get, 1,000 colonies on the supplemented master plate and 980 colonies on the minimal media plate, this indicates that there are 20 auxotropes that result from this cross. Now, the different genotypes are always the same whether or not you're dealing with a heterodimer or a non-heterodimer. What changes is the phenotype. So this genotype, as we've mentioned before, is always a prototroph. This genotype, again, always prototrophic. Okay. This genotype here is always auxotroph. It has the original MET1 minus mutant, and it's in the presence of the wild type version of the suppressor, which does not have an epistatic effect. So that one's going to be auxotrophic in both cases. And here's the one that's the key difference. In this case, this genotype, the wild type MET1 locus in the presence of the suppressor, in a non-heterodimer or a pathway suppressor, as we saw, this has a prototrophic phenotype, but in a heterodimer situation has an auxotrophic phenotype, in that this suppressing allele and the MET1 wild type allele do not work together to form a dimer properly in the heterodimer case. So with those genotypes and phenotypes now established, we can deal with this issue of, okay, we see 20 auxotrophs on the plate. The question is, are we dealing with a heterodimer or a non-heterodimer? In the case of a non-heterodimer, the auxotrophs are strictly the one genotype. That would mean that there are 20 auxotrophs and they're all this particular genotype. Now, as you know, once you have one of the products of meiosis worked out, you can infer the rest in terms of frequencies. So the other recombinant would also, there would be 20 of those present, indicating that there are now, out of the 1,000 cells on the master plate, that 40 of them are in fact recombinant. We could then go on to infer the other numbers as well. If there's 40 of these and there's 1,000 total, that would mean that these two total together 960, and then 960 divided by 2 is simply, okay, so 900 divided by 2 would be 450, and 60 divided by 2 would be 30, so together there are 480 in each of these categories here. Okay, so the recombination frequency in this case would be 40 divided by 1,000, or 4 map units. So if this is a non-heterodimer suppressor, we know that it is 4 map units away from the original locus. And if we wanted to draw a map, we would put the MET1 locus and the suppressor, if it's a non-heterodimer, and we would put them 4 map units apart, like so. In the case of a heterodimer suppressor, again, we observe these 20 auxotrophs on the plate, except now those 20 auxotrophs are split between 2 distinct genotypes. So we would have 10 of each recombinant and 20 in total. This would mean that the total recombination frequency would be 20 out of 1,000, or would be 2 map units. So if this is a heterodimer suppressor, then it would be 2 map units away from the original locus, and we would draw the map as such. And this is the case where we have a heterodimer suppressor. So the difference is that with the heterodimer suppressor, we have two oxytrophic genotypes. So the observed number of oxytrophs that you see on the plate is split between two genotypes. In the case of a non-heterodimer, we only have the one oxytrophic genotype here, which means all of the oxytrophs you observe on the plate are in this category, and there is a corresponding category with the same number of prototrophs. That's the other recombinant. This gives you different map distances. And in a question where I don't tell you the phenotype, or there's not a means to determine the phenotype of the key genotype, you would have to leave it at this and say, well, it could be this could be the answer, or this could be the answer, and we can't tell the difference. In most questions, I will give you the ability to determine if there are one or two oxytrophic genotypes. If there are two oxytrophic genotypes, it's a heterodimer suppressor. If there's only one oxytrophic genotype, then it's a non-heterodimer suppressor, and then you'll need to map accordingly.